So, good morning, everyone. In this video, we are going to see about one of the important analytical techniques called AAS, Atomic Absorption Spectroscopy. First, we can see the basic aspects and uh, principles of atomic absorption spectroscopy. So, AAS is an analytical technique that is used to determine the concentration of metal atoms or ions in a particular sample. So it will clearly review about how much concentration it has, the sample has. For example, metal atoms or ions present in the solution. So atoms or ions can absorb light at specific wavelengths and unique wavelengths. It means that characterized wavelengths we can say. Example, when sample containing, for example, copper, it is exposed to light at a characteristic wavelength of copper, then the copper atoms or ions will absorb this light. These are all the materials that can be reviewed through AAS. When the atom is exposed to its own unique wavelength, it can absorb the energy, it means photons, and the electrons excitement will happen. Electrons can move from ground state to excited state after it get absorbed. So the radiant energy absorbed by these electrons of the material is directly relates to the transition that occurs during this process. Okay, since the electronic structure of every element is unique, the radiation absorbed also represents a unique property of each individual element, and it can be measured. So by these electronic transitions through the energy, it means photons, uh, absorption of energy, after the excitements will happen, then it can be reviewed that what content it has or what material it has from this AAS. That's why it says the radiant energy is also absorbed by the electrons is directly relates to the transition that occurs during this process. So this is the simple instrumentation picture that uses a hollow cathode lamp and flame and all for atomizer. Finally, detector after it passes through the monochromator. So experiment. So we can use here liquid or solid sample that can be atomized in either in a flame or graphitic furnace. In the furnace, what they use it denotes here. The free atoms are then exposed to light, typically produced by a hollow cathode lamp, and undergo electronic excitations or electronic transitions from ground to excited states. The light produced by the lamp is emitted from excited atoms of the same element that is to be determined. Therefore, the radiation energy corresponds directly to the wavelength observed by the atomized sample. A monochromator is placed between the sample and detector to reduce the background interference. So from here, the detector measures the intensity of beam of light and converts into absorption data. This means the spectrum will get denoted here. So what are all the samples it can be reviewed? So solid samples and slurries also, and gaseous samples, etc. Here it shows polymers, some examples powders, polymers, etc. for solid samples, and for slurries in mode solid in liquid state, like that. And gaseous state samples, some basic samples, mercury, tin, etc. It can be reviewed through these AAS. So what are all the advantages and disadvantages, and where it after this it can be applicable. So advantages of AAS, it is very sensitive, highly sensitive, so that it can review exactly the sample has. Due to the sensitiveness, it can be also carefully handled, but the review of the sample would be maximum pure. So that shows its advantages of using AAS, and can detect approximately 70 elements. Research proved that more than or approximately 70 elements has been reviewed so far through this AAS, detected so far through this AAS. And detection limit, they have some detection limit for this AAS in order to avoid the error in the instrument. 20 microgram per liter, we shouldn't use more than that. And of course it required very small amount, pinch amount, for using this, for testing this. So with this very small amount itself, we can able to test what it has, what the sample has, can detect exactly. So first technique. So these are some of the advantages of using AAS, and what are all the disadvantages. Of course, a well-trained person is needed. More expert is needed. Who are using can handle all the aspects in that AAS. He can manage the error also, and technical person with very scrutinized in calibration is needed for this. And the instrument is of course very high cost. These are some of the disadvantages. And applications of using this, why we are using this. So qualitative and quantitative rapid analysis is very important. That's why AAS is very important among the researchers. Pharmaceutical samples in pharmaceutical companies also, they are using this AAS due to these reasons. So that their exactness, sensitivity, the rapid and exact result it shows. For this reason only, even environmental control samples can be reviewed through this. And agriculture samples, food and beverage industries, even in mining industries they are using. So what are all the materials present in, and how it has impurities. So what are all the impurities also present. That's why many industries are using this high costly AAS. Petrochemical industries also using this instrument to test their samples. And forensic, especially forensic, is very important to use these AAS. So it is a very versatile instruments that can be reviewed for many different samples, not only researchers but also for applications. But also it is useful for you know through these applications it is useful for public domain. Okay, so these reasons shows that importance of atomic absorption spectroscopy. Thank you so much.